So what we have understood till now is the different types of things what happens in the battery pack, communication, interfacing, performance management thing. Now let's start looking on the different circuit what is there in the BMS. So first one comes as a pre-charge circuit. What happens in the pre-charge? Why pre-charge circuit is required? We don't want inrush current beyond the limit. Now if there is a huge potential difference between the source and sink, then the quantity, I can say quantitative way of current would be very high. So using the pre-charge circuit, what we try to do, we bring the sink also to the similar voltage level. So my inrush current is within the limit. If there is a huge current flow, in that case what happens? Electronic components fails. One of the example here is the contactor which is connected to the battery pack and connected to the outside. Now if you have a pre-charge circuit, what happens? Before it start sending energy to the outside, it will, using the pre-charge circuit, the voltage level of the battery and the pre-charge and the contactor would reach to the similar level. So the current which is passing from the battery pack to the contactor is within the limit. If not, what will happen? The huge inrush current would flow. When huge inrush current will flow, many times what happens? The contactor is nothing but there are two conductors and a mechanism to connect the path. If huge current will flow, this path gets welded in, and if it is welded in, if you want to disconnect, it won't get disconnected. So it's a problem. So what you have? A spring loaded contactor, and this spring loaded contactor is activated using the BMS signal. If there is a huge inrush of current, these two terminals, this is a connection between contactor and outside. Now if this get welded because of the huge current, then you cannot disconnect it back on the need. So you don't want to have this type of situation. So what you do, you bring the voltage of this side to the similar voltage of the battery pack, and for that pre-charge circuits are used, where we use only MOSFET based relays or MOSFETs as a switching device. Still we use, because if there is a huge amount of current, then there would be local melting take place or the MOSFET will burn out. So what is a pre-charge circuit? It's a high resistance path. We provide two parallel paths. One path is your low resistance path and the other path is high resistance path. So we open only high resistance path so that the voltage should come near to the source. And once the voltage has come to near to the source, then we open the low resistance path so that current within the limit should flow. Otherwise, if initially itself we open the low resistance path, then huge inrush current will flow, and that could affect if it is electronic switch, semiconductor switch, or a contactor or relay type of switch by local welding or huge thermal stress because of those things. So how does it work? So you have a main contactor, this is the main path, and then you have a pre-charge relay. So it gets, this would be disconnected, this would be connected, so that your potential difference across this path becomes minimum, and then this get connected so that only the required amount of current flows through the path. So what we do, the pre-charge circuit is parallel to the contactors, while in contactors, when I say we are using the external relays or contactor, in the case of semiconductor switching, MOSFETs. this get energized at least 90% of the pack voltage before getting energized to the contactors, so that your huge inrush current should not flow. And you know, this is a fail-safe mechanism here. If any problem comes outside, a short circuit, or one tries to draw more current, it gets disconnected. If it gets welded, it won't happen. If MOSFET gets burned, it won't happen. Then another one is management control unit, and it's nothing but a microprocessor, Infineon. It could be of ST, and this is what you see here is that. What management control unit does? This is the brain of BMS. BMS is a brain of battery pack, and this management control unit, MCU, is the brain of BMS. What it does? State determination, in what state the battery pack is, its data acquisition as well as logging, pack control, electrical and thermal, all safety protection, communication. So all the software, embedded software, you feed into this, and this keeps on calculating, controlling all other subsystem of the BMS. In general, a BMS usually contains a master and the slave MCUs for redundancy purpose. That's what we were talking. If it is an integrated BMS, we can have one master MCUs, and then we can have something like this, slave MCUs, which will control if there is any. In that case, it has failed. So the first level of protection comes from here. The second level of protection comes from here. The latest MCUs, like from ST or from Infineon, can do a lot of things together. It can sense, it can predict, it can control several devices in one go. Then we have something known as cell balancing. Why it is important? If you see the two conditions here, the topmost, the cell is, all the cells are at equal charge and discharge level. However, in the bottom one, not all the cells are at equal charge level. And how do we determine that? By measuring the cell voltage. The SOC calculation depends upon the weakest cell. When I say weakest cell, which is the least charge, and SOC depends upon the cell voltage. Now, if your cell voltage is lower, let's suppose all the cells are of the same capacity. If one cell voltage is lower, that will have the least SOC, then other cells. Now, if I have to bring all the cells of that level, but what is shown outside is the lowest voltage cell SOC is shown outside. In that case, what happens? Even if your pack SOC is more, but overall your cell SOC is less, so you cannot take out the complete energy of the pack, because one cell will go run away faster. So in such cases, that's one condition. The second condition is that since all the cells are connected with each other, what will happen? If all the cells are at the not same voltage level, what will happen? There would be always an internal current flowing from one cell to other. And when we are saying these all the cells from one module or other module, there would be always an internal current flowing. And as soon as internal current is flowing, that means it's a charging, discharging, both the things are happening. And it's happening continuously if you are not making all the cell to same level. So both for energy perspective as well as the life perspective, it's important to keep all the cell at the same level, cell voltage at the cell level. But generally during the charging, or the during discharging, not all the cells get the reaches to the same level because of its health. So one cell may be at higher voltage, one cell may be at the lower voltage. But if we have to, but then the internal current will keep on flowing, and then you lose your precious life of the cell. To eliminate that situation, we do the cell balancing. And when we say cell balancing, that means we bring all the cell at the equal voltage level. Now, how to bring the cell, all the cells into the equal voltage level? So there are two ways. Whatever cell is at higher voltage, we discharge and bring it down to the lowest cell level, or discharge. Discharge could be passive and the active. When we say passive, that means we burn that energy using something known as resistor or MOSFET. The second is use that charge to bring up the lower voltage cells at higher side. That when we do that, then we say it's a active balancing. Passive balancing is easy, much easy. It is in your control. However, active balancing is slightly difficult, and that's why it is not widely used. In most of the places, because you need much more circuitry, much more control. So most of the places you don't want unnecessary balancing also to be happening. If one cell is weak and that always goes at lower voltage or higher voltage level, you don't want to keep it balanced always. But it's anyway happening actively, always it is happening, but you don't want to have it always. However, you have very less circuits involved in the passive balancing, and you have much more control over that one. And that's why the passive balancing is more preferred, even though you are wasting a small amount of energy. But benefit is you are able to predict your SOC much more accurately. Your cell life increases drastically. So basically, because of these two reasons, cell balancing becomes very important factor for a lithium-ion battery pack. What are the causes of imbalance? It might be due to different coulombic efficiency of the cell, due to different discharge current, variation in internal resistance, temperature gradient between the cells, because different temperature the cell will have different internal resistance. So unbalanced cell, this much energy gets wasted during the discharging, and this much of energy gets wasted during the charging, because you are not able to charge it fully, you are not able to discharge it fully. But if these all are balanced at the same level, in that case you will be able to discharge it fully, you will be able to charge it fully. You won't achieve the whole pack full capacity if you have unbalanced cells. How do we do? So there are two ways, as I discussed, active and passive. In the passive balancing, we basically dissipate the extra energy using the resistors or MOSFET. Drain charge from the cell above the balance set, whatever balance we have set, above that it will drain, and energy is wasted as a heat. In active balancing, move charge from the cells above the balance point to cell below the balance point. It's impossible to have zero balancing, zero differential voltage. Then you limit, okay, 5 millivolt, 10 millivolt, 20 millivolt, more than that I will not allow, I'll allow balancing to happen. If it is within the 20 millivolt, I'll say no balancing is required. In the active balancing, energy is not wasted, but yes, it can impact the cell life. So here is the application, how it is being done. You try to understand. Any question, you can write us back. Then next comes insulation monitoring device. It's an active safety device. It's present between hot conductor and the ground. what it does? It detects any unintentional leakage that happens between hot conductor and the ground. When leakage is detected, the IMD immediately shuts off HV circuits, and generally through a non-resettable error which you cannot reset, because now the problem is there. So you must call qualified service person or take your vehicle to the service center, who first detects where is the leakage, then rectify that, and then only can reset the error. Why it is important? So that passenger or equipment should not get in any trouble. High voltage DC is very, very dangerous compared to high voltage AC. However, it is not required in low voltage battery packs, that you can, if such type of situation happens, you can detect using the logbook, where it's measuring all the things. Even in the idle case, if you see some current is being drawn, that means some current is getting wasted because of there is some leakage current that is happening because of the contactor touching. And then as soon as you read, as soon as you are checking the data bank of the logbook, you can come back, see what is happening there and rectify that. But it is not dangerous to the passenger. You don't do any non-resettable error in the BMS in such cases. What are the benefits of having this type of devices? Your system reliability get increased, because if anything goes wrong, that can be taken care. Accident prevention, passenger will not get impacted because of that. You can monitor high voltage, low voltage side regularly, continuously. Avoids costly overhaul, because if that thing happened, and if passenger is not there, some local parts can get melted because of that. Some other equipment becomes in the faulty state, and repairing that would cost you a lot. So when such type of things happen, IMD devices help. So what we studied till now is different types of protection circuit, like pre-charge, IMD. Okay, any question till now?